Hey everyone, welcome back to Tech World. So today we are diving into a Leetcode medium problem that's not only fun to solve, it's also a great example of what you might encounter in a real tech interview. So let's break down the problem. Lowest common ancestor of deepest leaves, and the problem number is 1 and 2. So let's imagine we are in an interview at some company. So the interviewer says you are given a binary tree and find the lowest common ancestor of all the deepest leaf nodes. Hmm. Sounds like the combination of depth calculation and ancestor logic. So let's start peeling this on. So we are told that the deepest nodes are the ones farthest from the root. So we are not just looking for just LCA, we are looking for a common ancestor of only the deepest leaves. Let's take this example. So here, as you can see, the deepest node is marked in blue color and it's nothing but 7 and 4. And the common ancestor is node 2, which is marked in yellow. So here the output for this specific tree, it's going to be node 2. So this isn't a classic LCA of two nodes. Instead, we are trying to find the LCA of all the nodes that are at the maximum depth. That changes the game, right? So let's think recursively in this case. We'll need to traverse the tree to find the depth of each node, figure out where the deepest nodes are, and then work our way back up to find the lowest node that covers all of them. Sounds, in this case, take a pass and just think which approach we can use to solve this problem. So here, as you have thought, or so we can use post order DFS. We go to the bottom in this and then bubble info back. Let's say at each node we want to return a tuple, which will have two values, max depth in this subtree and the LCA of the deepest node in this subtree. Why? Because if left and right subtree have different depths, deeper side wins, right? So if the left and right are equal, then the current node is going to be the LCA. So let's take a case where we don't have 7 and 4. So in this case, the current node, which is the root node, is going to be the LCA, right? So that is what I'm trying to say. And so since we have gone through the problem, so let's try coding this out. So as said, we'll be using a post-order traversal approach. So here, first let's define a helper function, DFS, passing and by passing the node parameter into it. So here, just first write the base case. So where if the node is not present, we'll be returning 0 and null. So as I said, we are passing two values in the return function. So here uh, we'll have left depth comma left LCA, which is equal to DFS of node dot left. And for right depth, and right LCA, we are going to find the DFS of node dot right. And so now let's write our cases. So if we find the left depth to be greater than the right depth, we will return left depth plus 1 comma left underscore LCA. So here in this case, the left depth has higher values, so we are incrementing the values. So L if right depth is greater than left depth, we will return right depth plus 1 comma, right LCA. Else, if both left depth and right depth are same, so as I said, uh, we'll be returning the left depth plus 1, comma, node. That is the node itself. The node itself is going to be the LCA. So here, as a base case, we'll be returning, sorry. So here, we'll be calling the function root, and we would need the first parameter. So as I said, the function will be returning two parameters. One will have the depth, and the other will have the LCA, right? So we would need the LCA here, which is the second part. So we are calling that first object in this. So here notice how clean and elegant the recursion becomes when we pass both the depth and LCA input back up to the tree. So here if we see that if we have a tree with one node, it will return the root itself, and the tree where all leaves are at the same level, it will return the roots. And if the tree where deepest node lie on one side, we still get the correct LCA. So here, let's first run out this problem and check if we have any errors. Okay. Okay. The code seems fine. We'll submit this. So as you can see, the code is successful. So coming to the time and space complexity of this problem. So the time complexity is going to be O of n, since every node is visited once, and the space complexity is going to be O of h, the height of the tree due to the recursion stack. So that concludes our video. This is one of those problems where the trick is in returning just the right info from your recursive calls. By thinking clearly about what you need at each step, depth and LCA, you avoid messy global variables or multipath solutions. So if this helped you see the problem of recursion entries, drop a like and subscribe to TechBoy for more awesome videos. Got a better solution or you want a help visualizing this, you can hit on the comment. And until next time, keep learning, keep building. Cheers.